So let's go back to this problem that talked about the temperature versus the number of chirps that a cricket gives. And we're going to analyze this at a little bit deeper level. So let's first start with the slope. The slope here, m, is 4.85. Now I can think of that as being 4.85 divided by 1. Which means the rise of this graph, the graph is going to rise 4.85 units and run 1 unit. That really doesn't tell me much about the chirping or the crickets. So if I think about this being rise over run, the rise represents the cricket chirps. So I can say 4.85 chirps per, and the run represents the degrees, chirps per degree. So the way I interpret that, I say for every degree increase, for every 1 degree increase, the cricket chirps are going to increase by 4.85 chirps. Okay, that kind of makes sense, but how do you have 0.85 of a chirp? I don't know what 0.85 of a chirp looks like. So another way we can look at 4.85 is we can say 4.85 is 4 and 85 100ths. So I can say 485 over 100. And now I can say, okay, since the rise is 485, that's the chirps, the units here is chirps per degree. So another way that this might make a little bit more sense is I can say for every 100 degree increase in temperature, the number of chirps is going to increase by 485. That's good, but how often do we have a 100 degree temperature increase, right? So if we look at that graph here, we can say that this rise right here is going to be roughly 485, and the run is going to be 100. 485 chirps for every 100 degrees. Okay, that really doesn't make a lot of sense either. So let's write 485 as a fraction. So that's 97 over 20, a reduced fraction, 97 over 20. Now we're getting somewhere because now I can say there's 97 chirps for every 20 degree increase in temperature. That seems a little bit more realistic. If I look here from 40 to 60, let's just say, I can see that the rise over run, this is going to be a 97 here, and this is going to be 20. So that's the way I interpret the slope. Now to interpret the y-intercept, let's shift gears here. We're going to interpret the y-intercept. So I'm going to erase all this. And the y-intercept of this problem is negative 220.97. What does that mean? That means on the graph, the intersection down here on this graph is at negative 220.97. Or if I write that as an ordered pair, it's 0, negative 220.97. This is an x value, that's a y value. So how do I interpret that? Well, at 0 degrees, because x is degrees, at 0 degrees, there's going to be negative 220.97 chirps. Doesn't make a lot of sense. But that's how I interpret this in terms of the problem. Now, is it going to get to be 0 degrees? Sure, it can be 0 degrees outside, but can I have negative 221 chirps? I can't. So that's the way it gets interpreted. At 0 degrees Fahrenheit, there will be negative 221 chirps approximately. But this doesn't make a lot of sense. But that's the way I can interpret it.